The only thing I think of is the Diet Dr. Pepper one where it's the little itty bitty guy. He gets really high. High pitched. Alright. Sorry for forgetting about the bell ringer. Sorry for forgetting about the video, but we have it going now. So the most common response about how many zeros this polynomial has, so f of x equals 3x cubed minus 5x to the 5th plus x squared, right? We want how many zeros this has. Now first off, I do want to point this out. Looking at that equation, how do we know this is going to be a polynomial with those curves in there? Okay, so you're telling me that you think it's a cubic, but I'm just saying, in general, what do we see here that tells us it's going to be a polynomial? Any of them? Is it just, so like, I have to have x cubed in order to have a polynomial? Okay, tell me a little bit more about that.
Since it's the highest degree of 5, it's a degree of 5.
Okay, maybe, but I'm just asking, what should we look for to say it's a polynomial? For example,
F of x.
if I have this, is that a polynomial?
No.
If I have this, is that a polynomial?
No.
If I have this, is that a polynomial?
Yes.
So what makes this a polynomial but not those two?
Exponent.
So you're talking about that exponent?
Yes.
So then what about this? If I were to have this, would that be a polynomial?
No. Yes. No.
So one thing I'll point out is a negative exponent, remember, so a positive exponent is repeated. Remember, a positive exponent is repeated multiplication, right? A negative exponent is repeated. This is equivalent to 1 divided by x. Does that look like a polynomial now? No. This square root of x can be rewritten as x to the 1/2. That's the same thing as the square root of x. We won't get into why, but that's the same thing. Is that a polynomial? So what makes this a polynomial but none of the others?
It's a positive whole number.
Positive whole number. Not just a positive, because notice that's a positive exponent, right? But it needs to be a positive integer exponent or a whole number exponent. If you have x raised to a whole number exponent, that's when we see a polynomial. Does that make sense? So be aware of that. If it's a whole number exponent, you're looking at a polynomial. Okay, but I heard Lexi say earlier that because the highest degree is 5, or because the highest power is 5, it's a 5th degree, but you're telling me about the degree, right? So are you saying that that's the answer here, or are you just making that note that's a 5th degree? So,
I think it is the answer, but I'm also
okay.
saying.
So we'll come back to it in a second. I had, and I think these are the most common answers. I had some people say 10 and 3 would be the zeros. So could someone who said 10 share out why they're saying 10?
I think I know why they did it. They added things up.
Added what things up?
The exponents.
The exponents, okay. So should we have added exponents in this case?
No.
When do we add exponents?
When the number is multiplied.
Right. Remember, if I had factored form something like this, right now, how many zeros does that function have?
1.
That's 3, right? Let's say I dilate it by this function. How many more zeros do I now have? 5. And if I dilate that by this, how many more zeros do I now have? 2. So now I would have 10 zeros. Please note, you only add the exponents when it's in what form? Factored form. Does anyone know why though? Because you're multiplying. And when you multiply, right, so 3x cubed, right, and I know we would have to do a lot more than what I'm about to show, but the degree is only the highest power, so the highest power is only going to come from these terms. I'm only going to look at those for now. Negative 5x to the 5th times x squared. What's 3 times negative 5?
Negative 15.
And then I have x cubed, which means x times x times x And then I multiply by x to the 5th, which means I am now multiplying by how many more x's? 5, for a total of how many x's? 8. And then I multiply by how many more?
2.
So how many total x's do I have being multiplied now? 10. We add those exponents because when we repeatedly multiply more, right, we're increasing. Notice that word increase. What operation goes with increase?
Addition.
Addition. So you see how I have 3 right there, and then I'm increasing that by 5. So I have a total of 8 x's being multiplied now. And then I increase that again by 2. So I have a total of 10 x's being multiplied. But you only add those exponents when you have factored form because that literally is you repeatedly multiplying. Alright, so please be aware of that. And so when I do look up here, some of us said 3. Any guesses where someone got 3 from?
The first one.
The first term, right? Be careful. Does the highest power have to be the first term?
No.
No. I will say, traditionally it is. If this was written in the truest standard form, it'd be negative 5x to the 5th plus 3x cubed plus x squared. You do write your highest power first, typically. But when I look at it, I need to look for the highest power. Highest power is 5, so it's 5th degree. Does that tell us how many zeros it has, though?
No.
In behavior, we're going to talk about that more today. Okay?
I think no, because it could have like imaginary zeros or stuff like that.
But notice that you say imaginary, say it again.
Zeros.
Those are still zeros. Notice, not necessarily x-intercepts, but I am only looking for zeros, so do we count imaginary zeros? Yes. They'd still be zeros, they just wouldn't be x-intercepts. Yes, Aaliyah? Well, technically, if you look at a graph, be careful. The reason why this is a smooth curve is because there's infinitely many inputs. Each point would be have an input and an output. Does that make sense? And it looks like you're counting these terms here, right? But that, again, does not tell us how many zeros. Anyone remember what the fundamental theorem of algebra says? When including the multiplicity, the number of zeros is the same as the what? The degree. And we just said the degree is 5. So how many zeros are there? 5. Okay. Does that make sense? And so I did see, and the reason why I bring this up is because I saw some of those pieces and those logic on the test, and I need to address that for future understandings. It's going to come up again. But the highest power is the degree, and the degree matches the number of zeros. Not necessarily the x-intercepts, because we could have less x-intercepts, but it matches the number of zeros. Whew. Questions, comments, concerns? Let's get some good discussion in there. All right. Yes? You mean the test? Eventually. Once I finish grading it. Yeah. All right, so what in behavior do you expect negative f of x equals negative 3x cubed plus 4x squared plus 4x squared minus 8 to have? And we seem to be pretty split among these first 3. How are we supposed to answer this question? It's just in behavior. Say it again. We could put it in the graphing calculator, but I'll say this. I will expect you to be able to picture and understand the in behavior without me giving you a graphing calculator. There will be non-calculated portions where you have to do that. Amari. Okay, we always want to pay attention to is it, and when you say even or odd, what are you referring to? The even or odd? Say again. The highest exponent, which is the degree, right? It's an even degree polynomial or an odd degree polynomial. When I look at this one, is it even or odd?
Odd.
It's odd. So what does that tell me about in behavior?
It's going to go different ways.
Opposite directions? There's only 2 options then.
Yep.
Could look like that,
First and third.
or it could look like this. Which one? This one on the right? Because the leading coefficient is negative. Remember, when we talk about that odd degree, we have two options. The leading coefficient tells us which one. So notice as x goes towards negative infinity, what's my y going towards? Well, as it goes to the left, it's going up. So y is approaching positive infinity. As x goes towards positive infinity, what's f of x going towards? Please note, you will always have as x goes to negative infinity and as x goes to infinity for polynomials. Other functions, not necessarily, but for polynomials, you'll always have this piece. Always negative infinity and positive infinity, because that's the left and right hand side. You have to figure out what f of x or y is doing. What are your questions about this in behavior, though? We're a little split. We weren't sure about as x goes to negative infinity. Questions, comments, concerns? Stop talking, Mr. Kinney.
No one said that.
I know, but Jordan was thinking it, so I had to just put it out there. She laughs because she knows it's true. Yikes. All right. Getting back to where we were in the book. All right. So again, my challenge to you is to make as many what?
Inequality.
Don't read. In behavior of your polynomials, right? So you have a group to work with. Make as many in behaviors with those pieces as possible. When you finish creating that on your desk, you're going to get up and go to your different sections to sketch those out, right? I'll erase it from first block for sure. And so again, I think it was group 6 at the TV. It was a groups 1 and 5 at the chalkboard. And then group, who was at this whiteboard? This group 2, and then both of y'all were up here. Alright, so let's start making our graphs. I'll come and check after I erase things. Yes, Jordan?
No, you said you were going because I need to. I was having fun, but I don't think I'm going there.
Okay, hold on one second.
Right.
No great sense.
Well, remember, how many ends are there?
2 great
So you need
Am I going to sit to my body?
2 ends.
Yes. I would never. It reminded me
I had some that were very embedded now.
You're right.
Nah, I bet, dude, look at my face.
Jordan, you have been.
What?
But it's is this equation Oh, we need one. I don't think I'm doing this right.
Wait, group 7, did I put y'all over here? Y'all are there? Who did I put here then? Group 2. Thank you. What? Look, just create graphs
That's
here.
why I drew it back out. So I remember it. I'm gonna forget.
But create it here, put it up here, and we're going to have a discussion, and it's going to go in your book in a second. Create it here, sketch it up here, or over there, I guess, for y'all. And then, what? I mean, you can sketch it on here and take it over there if you want. But I don't see anything constructed.
That's because I already constructed it. I was doing it because I thought you were going to stop talking.
Well, I mean, talk about that with your group. Like, those are options. I'm not telling you what's right or wrong at this point.
Are we supposed to be trying to?
One thing I want to point out, though, is it's not going to just jut off. You see how that's starting to go up
Did you
pretty
make
quickly?
this chalkboard here?
Boom.
Did you do the chalkboard?
Yeah.
Oh, thank you.
A few days over spring break.
So you try to buy like some chalk?
So somebody else can
It's chalkboard paint.
Oh.
Where's the spray?
She stole it.
No, I'm just saying.
Hey,
If I'm at
Where's your, you already have your graphs done? Yeah? You have different as many different end behaviors as possible. So you go down. Okay, so go up to group 7 and draw it. If you want to sketch it on a sheet of paper and take it up there, you can, or if you think you can remember it, do that.
Did you already create? Did you create?
I'm about to die. That was doing.
What up? Huh? You don't want to spray it directly on it. It's not great for you. That was actually too much water.
Oh, no, that
You can't fit a bump out though, and that's on the bump.
Mr. Kenny.
Yeah, you should put up every graph that your group comes up with.
Okay.
Yeah, each of you should have different graphs. And put 4 up on the board. Or put up however many you come up with, how many different ones you come up with on the board.
Never been killed.
Are y'all ready to start graphics where we can?
Alright, we should all be in the different boards by now, putting different graphs up.
Now we gotta do who is using
Matt, look. I'm glad y'all I need you starting to know my
he called you bestie.
Get two different sections, get your graphs on the board. Let's go. Zaney, why are you touching your phone in the middle of my class? No. You don't even have a smartwatch on your First off, take this off your group. Second off, that would go.
Oh, I can turn it that way.
And then you see how that's going up right now? So then
Every time me and Chelsea talk together,
No,
because we.
that's how I'm telling the and the first time board
follow directions. Yes.
Okay,
Sure. Just make sure you're like, you see how it needs to keep that curve going. So that would be closer to what that polynomial would look like. Right, it's not going to jut off to the sides, it's not going to be straight down, it's going to have a slight angle to it. But y'all as a group should be working on this. Come on, you got stuff up.
That's just what I heard from the grapevine.
Really quickly, I need to clarify, you should only have one of each end behavior that your group develops. So I shouldn't see the same end behavior more than once. I need one example of every end behavior that you developed. So don't repeat end behaviors. I want as many different types of end behavior. You're excused.
He's like, you know, I know why him and Pete don't say how to quit. They act like I like him. He's nice.
Are there any others that we need to erase because we're repeated end behaviors?
Matt's harder. When I was a bit
If you do it, so
Okay. Are there any other end behaviors that we have? Thoughts or think about it? Alright, once your group is done, move back to your desk and we're going to go over this question. Give me quick, we're about to get going.
Dude, y'all do like totally each other. He's nasty. It's all of me. Dude. You would go swing just
Came up
here
and
use a common denominator plug and he discusses.
He wasn't even in this group. It was Clay and Cole.
It was all Clay and Cole.
I was looking for years actually. Go back to Blake. Go back to Blake.
Logan's ears are what got you going.
Huh?
Nice.
You stay there. Dude, Mr. Kenny, you know, Logan and Addison got to beat over flag football. That's what I heard.
Okay. Alright, come on, get all the different graphs up there that you can. And let's get seated afterwards.
I just always show. You still ask your question.
Okay, yeah. Wait a second, because we're about to go over this. Wait, who just walked out? Was that Alex? Oh, I thought you already know. Alright, so let's look at this. Let's have a discussion about these things. Alright, so I see only 4 options here. I see 4 options here. I see 4 over here, but we're going to have to address 1 or 2 of those. Okay, looking over here really quickly, are any of these being repeated? Which one?
Come on.
It's the first 2. It's the one Deja did.
This one and this one have the same end behavior, don't they?
Yeah.
Oh.
Yeah, Deja. Yeah, Deja.
Oh no.
Didn't I tell you not to say that?
Alright, hey. Oh yeah, let's talk about this one. Can this happen?
100% it can happen.
No. He only said it because he the one that drew it.
Well, Cole brought it up. So I want you to think about something. What we're studying are polynomial, there's an F word that's really important, functions, right? Does anyone remember what has to be true to make something a function? Ms. Estel talked about it, I think, as the vertical line test. What I always talk about, the defining characteristic of a function is that each input maps to one and only one output. And that's where the vertical line comes in. Drawing a vertical line here, this input, whatever this x value is, has how many outputs? 2. So is this a function? Does that make sense?
Yes.
So that would not be a polynomial function. It's getting a little too crazy with it. Alright? So we're not going to go with this. Okay, so we only have 2 end behaviors there. When I look over here, I've got 1, 2, 3, 4, 5, 6 graphs. But do any of these have the same end behavior?
Yes.
Which
The
ones?
pink and purple. Pink and purple.
Yeah, Cole.
The purple,
No, the other purple. No, the pink and purple.
this purple, and
Pink
which
and
one?
purple. And the pink
Oh,
one.
that one?
Yeah.
Alright, so I'm going to take one of those out.
Why do you have to pick one of
Which one? This pink one and that purple one?
Why you keep crossing out?
So, once we count out the multiples, the ones that are this, have the same end behavior, how many end behaviors do we have?
4.
We have 4. Okay? When I come over here to group 6, are there any of these over here that are repeats?
Yes.
Which ones?
The blue one.
The blue
in the upper right.
and the purple in the upper right?
Yeah.
Okay? We take that one out, how many end behaviors do we have?
4.
4. I come over here to group 2.
Somebody at the door.
Do any of them repeat? No. How many end behaviors do we have?
4.
4. Does anyone notice a pattern about how many end behaviors we can have?
Over.
Yes, Lexi?
So you can only have 4 in the
You can only have 4 end behaviors.
Yeah.
There are only 4 end behaviors. Pay attention to this. So this is a detail I would go ahead and write out under number 2. I'm erasing this to open up space. There are only 4 end behaviors. So, with that in mind, what do these 2 circled functions have in common?
They're both have an even.
They're both even degrees, not just exponents, degrees, right? Highest power is an even number. Okay, so what do these 2 have in common?
They have an odd degree.
Not negative, odd. Odd degree. polynomials, right? So we see that we have even and we have odd, right? So then what do these have in common? A negative leading coefficient. And these have a positive leading coefficient. So when I look over here, we've only talked about two different things that separate these functions, right? These end behaviors. What are the two things that are separating or categorizing these end behaviors? Degree and leading coefficient. And each of those options, or each of those characteristics, or those categories have how many options? Two. What I would do if I were you is I'd make a nice square in that space there, and I would put even degree polynomial, and then you guess what the second column would be? Odd degree polynomial. Negative and positive what? There we go, right? So a positive leading coefficient. By the way, does anyone know what letter we typically use for the leading coefficient?
LC.
N is usually the degree.
L.
Think about the quadratic functions we studied. A. Remember how it was ax squared plus bx plus c? A times x minus r1 times x minus r2. So what we're saying is that the leading coefficient A has to be greater than 0.
I was going to say because
Like, is this
A
like
is
the
the
first
first in the
coefficient?
alphabet.
Or is
So
it-
leading.
Okay.
Yep. Because it is the first letter in the alphabet, right? Ax squared plus bx plus c. If you have a cubic, it would be ax cubed plus bx squared plus cx plus d, so on and so forth. All right, so a negative leading coefficient is A, so the A is less than 0. So I don't care which graphs you choose, but you should put one of each graph in each box, right? So put an even degree polynomial with a positive leading coefficient. Put an odd degree polynomial with a positive leading coefficient. Here, put an even with negative and an odd with a negative leading coefficient. Now, right, so make a sketch and use notation to describe each case. So what are they referring to? Like once we sketch it out, what are we going to put inside of there? As x goes towards infinity, and so as x goes towards infinity, blank, and then as x goes towards negative infinity. So put a sketch of a graph in each of those to go with each of those features, and then work as a small group to develop that end behavior. I'm going to give you about 4 or 5 minutes to get those sketches in there. And by the way, you have a giant space here under number 2. I would use that entire space. The more space you have, the more details you can get in there. So if you have your sketches. Get your sketches out.
I know you might indicate.
Mr. Kenny,
Yeah.
what is supposed to be put on the line?
Okay, top left, an even degree polynomial with a positive leading coefficient. You see how it's the intersection of those two statements? So put an even degree polynomial with a positive leading coefficient right here. Like put a graph.
Please be quiet.
The way you say it though matters. And then also do the end behavior inside of there. Remember guys, we have lots of graphs all over the boards. Pick some to put into those different spots. Don't make it more complicated than that. Think about it. I would say, so remember, if it's even, the end behavior is in the, which directions? The same. So even. And if it's odd, the end behavior is in.
Yeah, it's like negative up.
For even, think about a quadratic.
No, but I think I'm pretty sure it's.
If A was positive, it was concave up. Does that make sense? I always connect it to the lowest even degree and the lowest odd degree. It makes it easier to see.
So, Miss Kenny, if it's a, positive,
Come on, dude. We're supposed to have 4 and do the end behaviors there.
and this,
I did go so
if
slow.
it's a positive leading coefficient, it starts out. I mean, it's big.
It depends. Which degree are you talking about?
Yeah, that's fine.
I want you to think about that. Is that a parabola? Or that is a quadratic, right? In that case, would your A be positive or negative? That one is?
This one?
Yeah. That graph you have?
Oh, the graph.
That'd be negative because it's concave down.
So it'd be like, no matter what, okay.
Well, I would label it no matter how you put it up there. That's why I put the labels on the box. Right?
Listen, Ken,
What?
you sure you ain't know Mr. Pinkerton before this year?
Huh?
You sure you ain't know Mr. Pinkerton before this year?
Oh no, I've known Mr. Pinkerton for years. We're just not related. We go to church together.
Like this.
She's sneaking this to you.
Yeah, I was gonna ask, but I don't wanna ask it then.
Yeah, I was like,
My mama had a bank we do all that extra stuff like Skype, everything, and then she make put the references on it.
Alright. That's been our 4 minutes. Let's talk about these and look at these. So a couple of things I want to point out, because a lot of us were struggling, I think, to remember which one goes where. So I just drew some examples up here, and I want you all to pay attention to this. What is the most basic even degree polynomial that exists? A parabola, a quadratic, right? A second degree? Yeah, that's even. What A value made it concave up? A positive. You see this fairly complicated, probably quartic polynomial. It's not just concave up, but does it have the same end behavior as a quadratic that's concave up?
Yes.
If I'm ever trying to figure out end behavior for an even degree polynomial, I just picture it as quadratic. Notice it's not quadratic, but the end behavior is the same, isn't it? And the reason why I say that it's not just a concave up is because, notice if I look right here, that piece is concave up. But what's this piece? Concave down, and then this piece, concave up, right? So when you get to higher degree polynomials, you actually have multiple concavities, but the end behavior stays the same. I did a simple quadratic here, right? Concave down with a negative leading coefficient. But wouldn't that be the same as something more complicated like this? For end behavior at least? So if I'm thinking about even degree end behavior, I'm thinking about a parabola. Like I'm just picturing a parabola, and is it concave up or down? That tells me my end behavior. Now look at the odd degree. Does anyone know an the most basic odd degree polynomial that we could picture it as? Y equals x and y equals negative x. No, it's not even a cubic, but y equals x, that's x to the first, right? That's odd degree. That would just be a line, wouldn't it? Right here. That line has what type of slope? Positive. That's a positive slope, isn't it? And it has the same exact end behavior as this super complicated odd degree polynomial. Could I use a line here to get the same end behavior? Yes. Right? Much more complicated. But I always picture the most basic versions of those even and odd degree polynomials and whether it has a positive or negative leading coefficient to know the end behavior. Alright? So please hear me clearly on that. Now, let's talk about the end behaviors that we would write. What end behavior, or what should we write every time to start on end behavior? As x approaches, say infinity or negative infinity. Now I do want to point this out. It doesn't matter, but I always start with negative infinity.
Is there any particular reason?
Yep.
Ooh, you know what else?
Yeah.
You want to keep a secret?
No, I'm going to tell you. So, looking at these graphs, does anyone know why I'm always going to look at as x approaches negative infinity first? We always read a graph left to right, don't we?
Yeah.
So I start on the left-hand side. That's it. You read graphs from left to right, so start on the left-hand side. It's logical, and it's going to help you with some other things later. What does f of x approach? Oh, by the way, notice I have this set up to match this,
Oh.
right? I have this set up to match this. So if you have enough space, you can go ahead and put this information inside of here. But if you didn't leave enough space, these match, okay? But as x approaches negative infinity, f of x approaches positive infinity. As x approaches, what's the next one?
Negative.
No, as x approaches negative infinity, now as x approaches positive infinity. Look at that again. As it goes to the right, it's also going. What are your questions before I have you do the rest of these?
What makes those two different?
What makes what two different?
What makes the first?
I got you. Notice this is as x goes to negative infinity, so as it goes to the left. That's the left-hand end behavior. This is as x goes to positive infinity, so as x goes to the right.
So it's the two different behaviors.
It's the two different behaviors, it's the two different sides, but with an even degree positive leading coefficient, it's going up on both of those. That's why these are the same. Yeah, good question. All right. Do the end behaviors for the other three. Actively collaborate to do the end behaviors for the other three.
Okay, I can work it out. Those would be as. Which one are those two? Negative.
Would it be
I think
as x approaches negative infinity? Okay, so for this second one, what is the opposite? Or like the one and the third?
How you worded that?
The one on the bottom left, would it just be the opposite of the first one? On top of it?
Oh, it's like you were saying it like you were losing.
Okay.
We were both laughing at
X.
Is this gonna be positive?
Someone say my name? What's up? I don't have an answer. Have you talked to your group about it yet?
You never talked.
Because they're talking about wolf.
No, we're not. We really just discussed it.
If you haven't asked them or talked to them yet, then I'm not answering your question. But you're in a group of four, not just Alex.
No, we're really doing. What are we doing? We really just discussed.
I will say this, I don't know if they stayed on task the whole time, but I have heard them actually talking about the math.
Just because we were playing a little game for 3 seconds, we weren't talking about it.
Okay. 60 more seconds to finish up your end behaviors.
You put
You know how
I don't know.
Which one are you looking at?
Don't do too much now, Naja.
As x goes to negative infinity, f of x goes towards. F of x is your x, your y.
So this one's positive, this one's negative.
Y. And it's going
Third one, they're both
Which
negative.
part?
down towards
Oh, I get it.
negative
Which part
infinity.
is it? So it's the negative infinity.
I'm trying to see the lowest
Positive leading coefficient.
Ooh.
Really bad. Both of these are negative.
Oh, Jesus.
The third
I know,
column,
but-
the one, yeah, but these are the.
I mean, I couldn't think of it.
They're all going.
All right. So let's bring it together. Let's share out ideas respectfully, meaning that we are going to raise our hand and I will call on people to have them share out their answers. But as x goes towards negative infinity, f of x, oh, by the way, this is an odd degree polynomial with a positive leading coefficient. As x goes to negative infinity, f of x goes towards negative infinity. And we clearly missed the directions there. Raise your hand and I'll call on you. Thank you. All right, Cole, I'll start on this side.
Negative.
Okay, does anybody want to push back on that or ask a question about that? James?
Just positive.
Positive infinity?
Yeah.
Agree.
Yes?
Positive.
Okay.
Huh?
Why? What's your evidence?
It's,
Because
it's
they
more, I can't,
change direction.
It does go in opposite directions, but look at this statement again. X is going towards what? Negative infinity. Okay, so Cole, do you want to stick by your answer or do you want to switch?
Yeah, I'm gonna stick with it.
Okay, why?
Because the f of x is the y, and
Okay.
it's going down on the left side of it.
oh, oh.
What do you think about that, James? What do you think about what he said? You don't know? I would say this, I want to add in an extra detail. You say f of x is going down, but specifically we've got to remember x is going to the left, and as the function goes to the left, it's also going
Down.
Which infinity is down?
Negative.
What do you think, James? Positive or negative infinity then? James, it's going down, my man! Like, you understand that these are negative numbers, right? Like, going down is negative, right? So, as it goes to the left, it also goes down, so it's going towards negative infinity. Now, look here, James, if we're looking at as x goes towards positive infinity, which direction is that? To the right. X is going towards positive infinity is the right. What's f of x approaching? Do you know, James? Positive infinity. Does anybody want to push back on that or ask a question? We're in agreement there? Okay, why is it positive infinity? What's going up? We give it that detail. Okay? Alright, who wants to look? We're now looking at an even degree with a negative leading coefficient. As x goes to negative infinity, f of x goes towards infinity. Anybody want to ask a question about that or push back on it? Clay thinks it's positive. Why do you think it's positive?
Oh, I thought we were talking about stable still.
Oh, no. Just weird. Alright, as x goes towards infinity, f of x goes towards 8n. Negative infinity? Anybody want to push back on that? Agree? Okay. Alright, now we're moving to an odd degree with a negative leading coefficient. As x goes to negative infinity, f of x goes towards positive infinity. And can you do the last one? Zany, I keep seeing you raise your hand. Negative infinity. Anybody want to push back on or ask a question about those?
Why is the infinity sign so wrong?
Why what?
Why is the infinity sign so wrong?
I can't hear you because Clay is talking instead of
She asked
listening
why
to
the
questions.
infinity sign is so hard to draw.
Oh yeah, it just takes practice. And then still it doesn't look good.
Oh, that's that
But mine looks like garbage. Not that it looks phenomenal now, but it looks like garbage all the way through high school, and then in college it started to get better, and I've been doing it for 15 years now, so it's halfway decent. Huh? No, my infinity. All right. Please pay attention. Hey, stop it, stop it. Could you memorize all this information about even versus odd degree and positive versus negative leading coefficients? Probably could. Would that be obnoxious?
Yes.
Is it unnecessary?
Yes.
Yes. Don't memorize this. We literally pulled that off of those graphs, didn't we?
Yes.
And so if I give you just, okay, f of x is equal to a negative x cubed plus 3x squared, I have no clue what's happening on the inside of that function. I don't know the middle of it. But what do I know is happening here?
Yes.
It has a degree of 3, so what does that tell me?
That, That's how many, oh my God, was that?
No, we're talking over each other. Hold on, we're talking over each other. Grace Ann, what'd you say first? First off, it's odd, so odd degree, so it's different in behaviors. What else? It's negative. So what does that tell us? It's going to go down. Remember, what's the most common or the most basic odd degree polynomial? A line? Would that have a negative or positive slope? So it looks something like this, like it has a negative slope. If I sketch that out, could I easily get my end behavior from it? That's what I want you to notice. All I would do to figure out my end behavior is I would do a quick sketch of what a cubic function might look like. I know the leading coefficient's negative, so it would be like a negative slope. That's it. And then from there I can get my end behavior. So you can memorize it, but I wouldn't. We clear on this? I have not memorized that. I guarantee I have not memorized that. I sketch it out every time. And I will say this, even if I haven't, if I don't sketch it out on the paper, I picture it in my brain. And based on a picture of a parabola in my brain, I can do my end behavior. Alright? So, questions, comments, concerns through number 2. I'm sorry you feel that way. I'll turn it over in just a second. Number 3. Create Pearl's polynomial using the axes to show the graph. So here's what Pearl said. Pearl said I can create this shape. I'm not going to say what it is, but we should recognize it immediately. This is a degree 2 polynomial with one extrema, an absolute minimum, and vertical symmetry. This function may have 0, 1, or 2 x-intercepts depending on how it crosses the x-axis. So go back to your boards that you were at. I want you to come up with a sketch of that shape once when it has 0 x-intercepts, once when it has 1 x-intercept, and once when it has 2 x-intercepts. Oh, come on. Yeah, 3 different options. Yeah, you can write that. Come in, 3 different options.
Chelsea. You wrote down wrong. You wrote down, turn it down.
No, I 67, I turned up 69. I didn't realize I was that one.
I think the move.
Matt, now.
Matt, now.
Yeah, Marty, you can all that. Make sure you label.
Read it out. So it's a
Don't spray the board. You spray
Oh my gosh, you
the washcloth.
Sorry.
Let's talk about this now.
It's a degree 2 polynomial with one extrema.
You told this so many times. No, stop. Let's get to work. Come on.
You have fun.
Don't forget, we need to work as a group. We need to be involved in the conversation. Sure, Marlon looks like he's trying to hide from the conversation.
No, I've been actually.
Wait, so does that take the bait off?
Can I see that so I can spray this out?
I know, I tried.
She sprayed all
You got plenty of space to do 3 graphs. Let's go. Are y'all done? Alright, grab a seat.
No, I'm doing the one.
Lexi, you have to hit the eraser button down at the bottom. I need us to hurry up. We got 90 seconds to get our 3 graphs up there. 90 more seconds, or 60 seconds at this point.
Mr. Kid.
That's gotta be it. None of them tell you, buddies.
That's 2 That's
We can throw the fines away.
The things. Yeah, you can throw the things away.
We don't need
15 more seconds and then we need to be in our desk.
No.
You gotta do five. I can't do that. You gotta do five.
Why do I need to get the mic?
He for real, he
I got
like,
a verbal altercation for sure.
he talks everything out. Cause he's not, he's a good citizen, he don't do all that extra. Right? Right, Mr. Kenny?
What?
You know what, I just spoke good about you and you wasn't even listening.
So Deja was asking a math related question. What's your question? What are you saying?
Nothing, I was just talking good about you.
Thank you. Thank you.
Thank
All right, let's talk about it. Let's look into here. There's a couple of things I want to address. First off, I want y'all to be careful. This isn't terrible, but be careful about this type of in behavior. Does anyone know an issue I might have with this?
It's going straight up.
It's going straight up, which means if it's going straight up, is it a function? No. It's a small difference, but you need to be careful that you're going slightly out and up, right? Because x is going towards infinity. Like it's going up more quickly, but x is still going towards infinity. 1. 2, I saw students doing this in first block, and so this made me think of it. Anyone see the issue with that?
Oh, okay.
They're eventually gonna cross.
Yeah, it's gonna go that way. Yeah, we don't want to do that. We also we don't want to go like this. That wouldn't make sense either. It needs to be a nice smooth curve. There should never be those joints like that. But there's another detail I want to point out. In the context, actually not even in the context of this problem, group 7 and group whoever that was used slightly different language. Which one is actually correct for this problem?
I'm gonna go with the chalkboard. They look good.
X-intercept.
Why are you saying x-intercepts instead of these zeros?
Because you can have more zeros.
We still know what zeros
Because the imaginary ones.
It is not even
Do something.
That's what it said, cause that's what it said on the.
Okay. Hey guys, what degree is this polynomial?
Second.
Second degree. How many zeros does it have to have?
2.
At least two.
So is this true? Do be careful. If it's second degree, it has to have
2.
2.
I said at least two.
No. It has to have 2.
2.
What y'all saying at least? Wouldn't that be the?
Cause
The degree matches the number of zeros. Remember, what really fundamental theorem tells us that the degree is the number of zeros?
The fundamental zero.
The fundamental theorem of algebra. It's not at least 2 zeros. If it is second degree, it is 2 zeros. Okay. So is it appropriate here to say 0 or 0 zeros?
No.
No, it is 0
X-intercept.
x-intercepts. But this still has 2 zeros. What would we know about those zeros?
Very imaginary.
We have 2 imaginary zeros here. Right? It's 0 x-intercepts, but that's still 2 imaginary zeros. Here we see very clearly 2 real zeros, so 2 x-intercepts. But what about here? And everyone had this, right? This is only 1 x-intercept. But what do we know?
There's one imaginary. I mean, one imaginary.
Tell me more.
Is it still?
There's still 2 zeros.
It bounces off.
1 0, and when it bounces off, it's with a multiplicity of 2. So maybe this is something like x plus 2 squared. Notice that would give me x equals -2 how many times? Twice. So it would have 1 0 with a multiplicity of 2. Remember, the fundamental theorem of algebra tells us that when you include the multiplicity, the number of zeros matches the degree. Right? When you include the multiplicity. And so again, we have 2 zeros, 2 zeros, 2 zeros, but the number of x-intercepts change. Questions, comments, or concerns? If you have not written this information down for number 3, I know there's not a lot of space, but I would do a quick sketch of those graphs, and I would note, 1, there's always 2 zeros, but here it's 2 imaginary zeros and 0 x-intercepts. So we gotta recognize those different cases.
How's your baby?
He's alive. You know, pretty good.
He's existing?
Yeah.
How many hours of sleep did you get last night?
Probably 4 or 5 max.
Is that better
He
than?
tried to keep me awake from like 2 a.m. to 3 a.m. or 4 a.m. It was rough.
How many hours? Probably 8 or 9.
Alright, let's look at number 4. Once you finish writing that information down, hopefully we all got it. Number 4. Novena created a graph of a 4th degree polynomial. However, Armando placed the x-axis on the graph and said that she is incorrect. That is actually a 5th degree polynomial. Who is correct? For the student who is incorrect, explain the error in their thinking. So, Novena is saying that this is a 4th degree polynomial, but Armando is saying it's a 5th degree. What do we see here is the reason that he's saying it's 5th degree? Lexi,
The, x-axis, or
there's something else there.
the imaginary and real zeros.
So if I count the 3 imaginary zeros and the 2 real zeros that he claims there are, I say claims because I'm not telling you if that's right or wrong yet, that would be 5 roots or 5 zeros, right? So that would be a 5th degree. So within your small groups, I want to give you a couple of minutes to hash it out, to debate it, to come up with an answer of what your group thinks of who is correct. Could this be a 4th degree polynomial, known as a quartic polynomial, or would Armando be correct that it's a 5th degree polynomial, being a quintic? Think about those different things that we have discussed. Let's get to discussing. I don't know that there is a special name for 5th degree. I've only ever heard 5th degree. Everything else we just call it 6th degree, 7th degree, 8th
I
degree.
thought he said it's 5 feet and
Oh, thank you. I think it would be.
I mean, it could be something else, but like, notice one of them saying that it could be 4th, the other one saying it's 5th. So think about what makes a 4th versus a 5th different.
It is.
The x-axis was right here, like on the first one in the middle. It could maybe be a 4th degree, which is the 2 x-intercepts being.
Oh, no, we're getting incorrect. Look. Yeah, that's what I'm saying.
I mean, the x-axis is only one axis. It could have multiple x-intercepts, right? So like, you can only have one x-axis.
Yeah.
yeah, I don't know.
But you might think about how what's wrong with the little part right here, the imaginary.
Neither. Why? No, neither is not an option. It's either Novena or Armando. So talk about why you think it's Novena, and we'll have a whole conversation on why.
Because I was asking like,
Hold on, we need to have a we need to discuss a thing. So, whole chair ideas and then add on and push back on it. I will say it won't actually change the type of function. Depending on where you are, it might change the type of groups we can use, but it won't change the type of function.
and you did this.
Except if you put it right there, it'd be one real word, and they multiply the other.
You gotta do that.
Well, so I will point out, doesn't that kind of look like a like, if you were to figure out why he's X cubed, that's probably what he's thinking about. So it's probably, that's why he's probably saying that. You're missing one of the most obvious things to prove it one way or the other.